10, we were looking at answering the question about, where do these pollutants come from? We know in our natural world that the atmosphere is mostly made of nitrogen and oxygen, and that's just the way the Earth has evolved. But we recognize that through human activities, especially the burning of fossil fuels, we have managed to create pollution. And so and most of the pollution comes from what we call a combustion reaction, which is a type of chemical change. It's a type of a synthesis reaction, in particular in which the compound or the element combines with oxygen. We looked at some examples of some different combustion reactions, and then at the very end of the lecture last time, we looked at some emission data from a emissions test for somebody's car. And what we recognize is that the emission test is testing for carbon monoxide, NOx, which we haven't talked about that yet, carbon dioxide, and hydrocarbons. And the hydrocarbons are also called VOCs, which stands for volatile organic compounds. So we want to continue talking about, how we create these pollutants. It's a combustion reaction, yes, but we want to know what are the problems with these pollutants. Why are they dangerous to people? And then once you understand where they come from and what they do to you, you can figure out better ways to limit the production of the pollutants and or avoid them. Okay, so I'm going to switch now over to the document camera. Most of our pollution issues come from the burning of fossil fuels, like we said. And that occurs in automobile engines. That's why we looked at the emissions report last time. And coal-fired power plants. Last unit, we were looking at nuclear-fired power plants, and there was not an issue with air pollution with the nuclear power plants, but rather we had the issue with the spent nuclear fuel. All right, we have a whole other pile of problems with the coal-fired power plant. So we're going to look at each one of these in turn, these direct sources. We're going to look first at the automobile engine and the types of pollutants that we get from that, and then the coal-fired power plants. Okay, so the last time we were looking at this emissions report, it was sort of out of focus, so we get a chance to take a look at it again. Fortunately, let's try again. This time I'll operate the equipment better. All right, let's try to focus this up so we can see it a little better. Whoops, wrong way. All right. Oh, okay, that looks good. So last time we were looking at the hydrocarbons. We said that normally when the EPA is reporting hydrocarbons as a pollutant, they call it VOCs, which stands for volatile organic compounds. And hydrocarbon being the particular type of volatile hydrocarbon. And it's volatile because if you've ever pumped gas and you spilled a little bit on the ground or around your car, you recognize that it evaporates very, very quickly. So that's why it's called volatile. And in this emissions report, you can see, they're checking somebody's car to see, do their volatile organic compounds, or in this case, hydrocarbons, fall below what's considered a safe limit, which is where the green line is. So in this case, reading this graph would be 2 grams per mile, 2 grams output per mile driven at these various different speeds. This is what you're going to get. And we talked last time, you can see the speed is the blue line, so you can see you're going with time faster and faster. This is faster speeds. Right down here, they've stopped it, so it's just idling. And this is medium speeds, okay? And you can see how the hydrocarbon, in this case, it looks like most of the hydrocarbons, the higher concentration occurs at the lower speeds. That makes sense because most cars, the optimum speed is highway driving, around 50 miles an hour. That's where the hydrocarbon is the lowest output. And then we looked at the carbon monoxide, saw that the highest output was at idling or very, very low speeds again. We think that probably has something to do with the oxygen concentration being compromised at those low speeds. All right. And then the NOx, we'll talk about that in a little bit. And then the carbon dioxide. So this is what we looked at last time. So these are some common pollutants. The carbon dioxide, again, is not considered a pollutant. It's checked to check the overall efficiency of your engine. All right. So What's the problem with these particular emissions? Let's look right now at the VOCs and the carbon monoxide and the carbon dioxide first. Like, who really cares if we have too much of that being output? So let's zoom back. Oops. Let's get ourselves organized. All right. So what's the problem? Well, the VOCs are the hydrocarbons. That's a result of the incomplete combustion. And the problem with the VOCs, as it turns out, well, maybe not so obviously, but if you breathe a high concentration of hydrocarbons, it can make you dizzy and give you a headache and that sort of a thing. But also, even more importantly, is it leads to the formation of ozone. And we will talk about this in a few minutes. Okay, that's another nasty character. The carbon dioxide, the problem with carbon dioxide is too much carbon dioxide in our atmosphere is leading to climate change, sometimes called global warming. We're going to talk more about this later as well. Actually, in chapter 3 of the book, we'll have a whole chapter devoted to the issues around carbon dioxide and how that seemingly harmless, gas that we all produce all the time is leading to climate change. The carbon monoxide is really poisonous. Okay, so this is just as a pollutant, as it comes out of your car or any other situation where you're burning fossil fuels in a limited oxygen capacity, it is a poison. At high concentrations, it's lethal. It will kill you. At low concentrations, it can give you a headache, dizziness, nauseousness, and it can be very serious for people who already have cardiovascular disease because it's compromising the amount of oxygen that is carried to their body, and it puts stress and strain on their heart and lungs, which can lead to a heart attack. So the reason why it's a problem is because the carbon monoxide blocks the absorption of oxygen in your lungs. When you breathe in air, your hemoglobin in your red blood cells is a type of a protein in your red blood cells that makes your red blood cells red. But the hemoglobin picks up oxygen in your lungs and carries it to the parts of your body and deposits it, and then picks up carbon dioxide and carries it back to your lungs for it to be exhaled. That's how your body works. And the problem with carbon monoxide is that it will attach to the very same place on that hemoglobin where the oxygen needs to attach on the iron in your hemoglobin molecule. It will attach and it will not come off. So whereas oxygen attaches on and off, depending on the pH of your blood and whatnot, it's going to pick up the oxygen, it's going to dump it off where your body needs it, and it's going to pick up carbon dioxide on the way back to the lungs. The blood does, but the carbon monoxide sticks right to that hemoglobin in your red blood cells, and it then once the carbon monoxide is stuck on, the hemoglobin is no longer available to pick up oxygen. That's why over time, more and more of your blood will get saturated with the carbon monoxide, and then you're carrying less and less oxygen to your body. That's why you get a headache and dizzy and feel sick to your stomach first, because that's the effect of depleting your brain of oxygen. And then finally, you'll pass out. And if you have no way of moving your body away from the carbon monoxide, then it can kill you. So it's nasty. So obviously we recognize that. Even I just tell you a little side story. In traffic police in some cities in Japan where it's very, very densely populated and they have a lot of car traffic, the traffic police, because there's so much carbon monoxide emissions, will have to take breaks where they go breathe in 100% oxygen from an oxygen tank, and under that situation where you have a very, very high concentration of oxygen, like in air it's only about 20%, but if you breathe in 100% oxygen, it's enough to knock the carbon monoxide off. And so you can be treated for carbon monoxide sickness or poisoning, but you have to get yourself some 100% oxygen from an oxygen tank. Okay, so you can be treated, but you got to catch it in time. So sometimes people who are exposed chronically to carbon monoxide will have to go breathe some 100% oxygen to knock that carbon monoxide off.